Welcome students. Now we are going to start the topic impulse from the chapter motion in a plane. So now begin the topic impulse. Impulse, that means the product of force and time, means force F and time T, that produces a finite changes, that means measurable changes in momentum. Student, in the earlier class we saw that momentum is commonly used in the sports. The mean of that, a force that changes the velocity of an object. Either way, also object velocity changes, so momentum also changes. What is the mean of that with the momentum? Impulse in physics is a term that used to describe the quantify effect of force, that how much force is applied on the body. Force applied, how much force applied on the body, okay, acting over the time to change the momentum, acting over the time, okay, to change the momentum. That means to change the momentum, we need to sometime, for example, we have some ball. We want to throw that ball. So what we do, we just do back them our hand and then throw that ball. So from taking to doing back our hand, there will be some time lag, okay, and we need to apply some force. That how much force we have applied, that kind of a thing which is described by the momentum, and change in momentum is nothing but impulse. Okay, it is represented by J usually, okay, it is represented by I usually, okay, and in some books this will be represented as a J. Now for example, if I'm moving ahead, for example, collision between the billiard ball, nail driven a wall by striking it hammer. Unit of impulse. So impulse J is equals to Ft. Impulse is a vector quantity, student. It is an vector quantity. So vector J is equals to, as we know, force is also vector quantity. So vector F into T. What is T here? Time. F force and J impulse. In case of a CGS system, its unit is a dyne second. In SI system, Newton second. So dimensional formula of impulse is MLT minus 1. How we calculated? Let's do. So we know that J is equals to Ft in magnitude. The dimensional formula for magnitude is MLT minus 2. T is the time over here. So again T. After solving, we get this value MLT minus 1. I hope you understood like how this dimensional formula came. One thing which you have to note, impulse is a vector quantity that we understood earlier, whose direction in the direction of force. Okay, so impulse is a vector quantity whose direction is in the direction of force. In which direction? The direction of force. Impulse and momentum. There is a minor changement, we can say difference between the impulse and momentum. What is that? So impulse and momentum both describes the amount of force which is needed for changing the momentum. Okay, But the change in momentum, like from second law of equation, from second law of motion, we can say that force is a dp by dt, okay, and that change in momentum with respect to time is defined by a force. So we can say dp is equals to force into time. Clear? And that change in momentum is defined by the impulse. So we can say I is equals to, if we remove this integration symbol, so we get integration sign, means, as you can see, this is an impulse. This is a continuous graph, as you can see. So a force acting on the particle may vary with time. So how much time, how much particle actually varied with a particular at any particular time, okay, or at a particular duration of time. Duration of time. This is defined by the term impulse. Okay. The second example we have another also, as you can see, pulling away from the punch, going into the punch. We need again apply, we have to apply some force, but that thing occur in some time. That force related with the time generate a new term, that is a momentum. Okay, and that momentum is continuously changing with respect to time. So that change in momentum is called as impulse. Now I think now you will be able to understand the things. So if force is a constant, then what is the mean of impulse? Then impulse will be J is equals to vector Ft. So according to second law, that vector F is equals to vector dP by dt. That means vector F dt is equals to d vector P, P2 minus P1 is equals to mv minus mu. Impulse J is equals to F dt, means mv minus mu. If the force is a variable, then impulse will be vector J is equals to T1 to T2 with integration sign. What is the T1 and T2? Lower limit, and T2 is upper limit. What this integration sign shows? Continuously summation. Continuous summation means changement, when changement occurs in the minute to measure. Okay, that must be continuous in nature. The area under the Ft graph gives the impulse. If vector F acts on a body, the time T1 applies for that, and F2 for T2, and similarly F3 for T3. Then total change in momentum is equals to vector F1 T1 plus vector F2 T2 plus vector F3 T3. So application of impulse. For a given impulse, the average force is inversely proportional to the time for which force act. For example, we have a few examples also, like a person is falling on a concrete floor from a certain height, receives injuries from more than falls the same height as a loose soil. What is the reason behind that? When like when the person is start to fall, for example, this is a person at a particular height, they start to fall, and here they have that have two types of a surface. One surface is a loosely, okay, that is a, and next is a concrete. So in concrete, person not move more than depth, but in soil the person can move more than depth. So as you can see, that force is inversely proportional to T. If T is more, then force will be less. Okay, because of that, when a cricketer, okay, uh, a cricketer person catching the ball, so that time his hand not upward in the direction. He trying to catch the ball, okay, by doing hand downside. So that time will be more and force will be less. Clear? Breakable articles like China war, television sets, etc. are transported from one place to another by packaging them with felt styrofoam. Again, because of that, the particle which is struck by the like foam that carries maximum time. Because of that, the force will be less and damage will be less. Shock absorber are used in vehicles to reduce the magnitude of impulsive force. A cricketer lowers his hand, as I told you in the previous example, a cricketer lowers his hand while catching the ball to reduce the impulsive force. I hope these examples are suitable for these topics. So, and you must able to understand the basics of that. Now let's move with the multiple choice questions. First, formula for impulse. Force into time, force into acceleration, force into speed, and none of these. The correct answer for this question is force into time. As I told you earlier, like what is the mean of momentum? And the formula for momentum, P is equals to M into V, or P is equals to F into T. Clear? P is equals to F into T. Wait. Now it will be good if I'm writing delta P is equals to F into T or delta T. Clear? And what is the mean of impulse? Impulse is nothing but change in momentum. Clear? So that will be F into T. As you can see here also, the product of force and time that produces an finite change in the momentum of the body is called as impulse. What is the dimensional formula for impulse? MLT minus 2, ML to T minus 2, MLT minus 1, ML to T minus 1, M to L to T minus 1. The correct answer is what? MLT minus 1, C. If need, so I can do the calculation here also. F into T, as I told you, T is nothing but a time. So force MLT minus 2 and time, as I told you, T. After solving, we get MLT minus 1, which is option 3. I hope it's clear. Moving ahead with the next question. A cricketer lowers his hand while catching the ball is an example for impulse, momentum, force, or both B and C. The correct answer for this question is impulse. Okay, a cricketer lowers his hand while catching the ball to reduce the impulse. What they are doing? Impulsive force they are reducing. In the most of the question of in IIT-JEE and in NEET also, they are asking in a 1 marks like a cricketer lowers his hand while catching the ball to dash the impulsive force, reduce, increase, okay, and all of the above, none of these, like that, a kind of substance. So the correct answer is to reduce. Third law of motion. Newton's third law of motion: to every action, okay, there is an equal and opposite reaction. Student, every action means if we are doing any, try to change, okay, try to change the position, okay, shape, direction, etc. in any body, okay, in any body. So if we want, like to every action, if we want to change the position, we are doing the action. We want to change the shape, again we are doing the action, okay. So to every action, there is always an equal and opposite reaction. Now, student, what generally they are doing mistake from your side, students, few of them are doing mistake. Newton's third law of motion is applicable not on the single bodies. Like, for example, I had just taken a sheet of paper, and in that sheet of paper, I just placed a water bottle. Suddenly, or we can say quickly, I'll just pull that sheet. What happened? If I pull that sheet in this direction, the water bottle just fall down in the opposite direction. Here, I action did in the sheet, and reaction we get in the opposite direction again, but this bottle. Clear? So, third law of motion always occur with different bodies, not the same bodies, with different bodies. Again, in NEET examination, that question asks that Newton's third law applicable for a single body, for different bodies, okay, these type of question. So the answer is for different bodies. This is an action and reaction. Okay, again, as you can see this rocket, okay, rocket is moving upward, okay, because of the fuel, okay, and but fuel is what? Fuel is burning, reducing, so reaction force is in opposite direction. So fuel are filled in this rocket, but rocket and fuel both are different things. Now moving ahead, like what does it means? So this means that for every action there is a reaction which is equal in magnitude but opposite in direction. Okay, equal in magnitude but opposite in direction. Student, what is the meaning of magnitude? A numerical form. A numerical form or numeric value of any, wait, yes, a numeric value, like force, I'm applying 10 Newton. Okay, so what is 10? This is in magnitude. Okay, work 10 Joule. So what is 10? 10 is magnitude. But applying in the direction of east. East is direction. Clear? So the numeric value, numbers are related with the magnitude. As you can see in this diagram also, a person which is running in the boat, the person can jump easily with this platform, but the boat is doing reaction back. So person is a different, okay, perspective, and boat is different. Means both the things are different, not in the same. So again, I just want to repeat my statement. Newton's third law is applicable for the different bodies, not a single body. When you push an object, it pushes you back. Characteristics of action and reaction. Action are and reactions are equal in magnitude but opposite in direction. Action and reaction do not act on the same body, as I told you many times. They not act on the same body. Okay. Therefore, they do not cancel out each other. Clear? This also question came in the NEET examination as well as many competitive examination. Okay, that action and reaction are applies on the same body, like this kind of a question, or not. Okay, and therefore do not, sometimes in the assertion it will become action and reaction do not act on the same body. Reason, because they do cancel out each other like this. So what was the answer for that? The assertion is correct, but the reason which is given, that is incorrect. Okay, assertion is correct, but reason is wrong. Moving ahead, action and reaction are mutual. Okay, and act as simultaneously, means they both act, okay, simultaneously. When the action occur, that time reaction occur, but on the same body it's not. Okay, not like that. They are mutual, means they are in the contact. Newton's third law not applicable for the pseudo force. Okay, now here is a concept new, that is the pseudo force concept. So what is this pseudo force? Here just I want to elaborate more. Pseudo force is a force which is actually not present, okay, but working, that kind of a thing. Newton's third law defines the nature of the force. Who gives the magnitude of force? Newton's second law, that means momentum. Who gives the change in momentum? Impulse. And gives the law of a conservation of a linear momentum? Newton's third law. Newton's third law is not strictly applicable when interaction between two bodies separated by a large distance. Okay, means as you can see by this will be a mutual contact. Okay, but the bodies if separated at a more or large distance, it will be not like that, that Newton's third law always applicable for that. Okay, what is pseudo force? As I told the question earlier, so force acting on an object relative to the observer in non-inertial frame without any interaction with any other object in the universe is called as pseudo force. So force acting on the object in relative, as I told you, relative means which can like if the one body is changes, simultaneously other can change. Okay, other may change. So observer in the non-inertial frame. We have two types of a frame in students. One is inertial. Inertial frame is those frames where Newton's laws we can apply easily. Okay, we can apply easily, or we can see laws. Newton's laws holds good, but in non-inertial frame of reference, Newton's law does not hold. That's why we are saying that pseudo force concept, because this will be not applicable actually. This will be not following actually Newton's laws. Okay, but yes, of course, this will be applying. For an example of centrifugal force, I'm just giving one example of centrifugal force also, like where it will be applying. So if I'm just taking a stone and like this boy is holding a stone in his hand and trying to just circulate this ball. What happen if they suddenly leave this thread? The ball or the body start to moving outward. We know that when the bodies start to revolving, there is a centripetal forces applying. Centripetal. So what is the direction of centripetal force? Towards the direction at the center. So the ball is actual moment of the ball is where? That will be in the center, but it will be moving away. So there is a need to some kind of force applying in the upward direction. Okay. But what is that force? That is a centrifugal force. It's not actual force. It's a pseudo force. Deflection of pendulum relative to the accelerating car, gain or loss speed experienced in an accelerating elevator. So a bird flies forward by exerting a force on the air, but the air pushes the wing of the bird back, makes the bird move forward. Walking. So force exerted by a person on the ground. Force exerted by the ground on a person. This is the action and reaction. Now moving some multiple choice question. Centrifugal force is an example for gravitational force, tangential force, pseudo force, or external force. The correct answer for this question is pseudo force. So force acting on an object relative to an observer is non-inertial free. Without any interaction with any other, the object is in the universe is called as pseudo force. Now the second question which we have, which of the following statement is incorrect for action and reaction forces? These act on two different bodies. These are equal in magnitude but opposite in direction. These act on a single body's action and reaction never balance each other. So as I told you earlier, students, many times that these act on two different bodies. That will be correct statement. These are equal in magnitude. Okay, that means equal in, there will be magnitude. Okay, but opposite in direction. This will be also correct. Act on a single body. Many times I told you in the NEET examination, these type of questions came that it will be not act on the single body. So this is a wrong statement, and according to our question, that which of the following statement is incorrect? So the correct option is C. Okay. And the last option which is also correct, that is means correct according to the real statement, action and reaction never balance each other. Okay, because it will be applying on the different bodies. Third question we have, the behavior of the body under zero resultant force is given by Newton's third law of motion, Newton's second law of motion, Newton's first law of motion, and Newton's law of gravitation. The correct answer is Newton's third law of motion. So students, this is all much about for today's class. I hope you studied the topic and you understand it. So if you have any doubt, any kind of confusion, you just may ask in the chat session. Till that, take care everyone.